All right, today we're going to be looking at lesson 8.1. We're looking at pure imaginary numbers. It's going to be a new topic. We haven't really mentioned this before, maybe in passing. Our objectives today, we're going to express square roots of negatives as imaginary numbers. We're going to take a look at that and why we need that. Simplify powers of I, which is the imaginary number, so we'll obviously be talking about that. And then solve quadratic equations. I've got a typo there, of the form x squared plus c equals 0, where c is greater than 0. We've actually done it before if c is less than 0, but today we're going to be looking at if c is greater than 0, and that will make more sense to you as we move along. So let's talk about right now the need for imaginary numbers. So we've been solving equations here throughout the year. We've solved linear equations, we've solved quadratic equations, and this fits a quadratic equation, but we're going to run into a problem here. So to solve this, we would subtract 4 from both sides because we're going to get x by itself. And we'll get x squared equals negative 4. To solve a squared, we would take the square root of both sides, and we put plus or minus here. And here we have x equals plus or minus the square root of negative 4, and then we think, well, what times itself gives me negative 4? Well, we might think 2 times 2 is 4, so negative 2 times negative 2. But negative 2 times negative 2, that's a negative times a negative, so it's still a positive. And so here we run into a problem, and this is where we get the need for imaginary numbers. So what we'll do right now is we'll take a look at what we can do with this answer to write it as an imaginary number. There's no solution in the real numbers. We have to look into imaginary numbers. So here we have the definition of the imaginary unit, or the imaginary number, I, where I squared is negative 1, and so that if we took the square root of both sides, we would get I equals the square root of negative 1. And so on that previous problem, when we had the square root of negative 4, we could think of this as the square root of 4 times the square root of negative 1. Square root of 4 is 2, and we now have a definition for this square root of negative 1, and that's I. So our answer would have been 2I. Actually, we would have had a plus or minus 2I. So what we're going to do now is we're going to look at the powers of I, and we're going to try to see a relationship here and see if we can come up with some sort of pattern and figure out what we can do with this. So before we learned I to the 0, anything except 0 to the 0 power we learned is just 1. I to the first, that's just I. So I squared we can think of as the square root of negative 1 squared. Well, we know the square root of negative 1 are square roots squared, they cancel each other, so this is just equal to negative 1. And then the last one here, I cubed, which this thing is in the way, but I cubed. What we're going to do is we're going to think of I cubed as I squared times I. Because when you add the exponents, a 2 and a 1, that's I cubed. And then here we know that I squared is negative 1, and we just have a negative 1 times I, which is negative I. And I have these listed in this way for a reason, so we have 1, I, negative 1, and negative I. So let's go to I to the 4th. Well, I to the 4th, we're going to rewrite that in a different way. I to the 4th we can write as I squared times I squared, using our rules for exponents. I squared times I squared is negative 1 times negative 1, which is just 1. So I to the 4th, as we work through that, that's just 1. And now we're going to use that I to the 4th. That's going to be really helpful, that I to the 4th is 1, as we look through the rest of these, because we're going to write them all in terms of something to the 4th power. So I to the 5th, we can think as I to the 4th times I. So I to the 4th, again, we just said that's 1, so we have 1 times I, which is just I. I to the 6th, again, we're going to write this. We're going to have I to the 4th, which is just 1, times I squared. I squared is negative 1. We see that right across negative 1, so this is equal to negative 1. And then I to the 7th, hey, we're going to use I to the 4th times I cubed. I to the 4th is 1. I cubed, we look right across here, that was negative I. So I want you to look at a pattern here. We have 1 and 1. We have I and I. Negative 1 and negative 1. Negative I, and this pattern will continue. So we'll see I to the 8th, we could think of I to the 4th times I to the 4th, which that's 1 times 1, which is just 1. So we see that pattern continues. 1, 1, and 1. I to the 9th, well, we just saw I to the 8th is 1, so we'll go I to the 8th times I. I to the 8th, it's just 1, so this is I. I to the 10th, well, that's I to the 8th times I squared. I squared over here, we see is negative 1, so this is just negative 1. And this can be written as I to the 8th times I cubed. I to the 8th is 1. I cubed is negative I, which we see across there again. So hopefully you see a pattern here. Anytime you have a multiple of 4, here we have 0, 4, 8, we could have I to the 12th, I to the 16th. Anytime it's a multiple of 4, this is just going to be equal to 1. Anytime it's a multiple of 4, anytime it's 1 more than that, it's I. Anytime it's 2 more than a multiple of 4, so 2, 6, 10, the next one would be 14, you're going to get negative 1. And anytime you're 3 more than a multiple of 4, you're going to get negative I, and then it would repeat. And it would go back to this, and it just keeps repeating. So we can summarize this in saying, so we'll divide the exponent by 4. The remainder is going to tell us what we'll have. So if the remainder is 0, it's going to be equal to 1. If the remainder is 1, so that's like up here, remainder being 1. If the remainder is 1, and remember we're dividing the exponent by 4. If the remainder is 1, we get I. If the remainder is 2, we get negative 1. And if the remainder is 3, maybe I should put an R here, remainder 1, remainder 2, remainder 3, we'll get negative I. And so now, knowing this, so when we do this, we're going to divide our exponent by 4, and whatever the remainder is, that can help us find what the value of that actual imaginary power is. So what we have, I to the 35th, 35 divided by 4. Some of these you should be able to do in your head. 35 divided by 4, I'll write it. That's going to be 8, remainder 3. So we got a remainder of 3. So we look up here, remainder of 3 gives us negative I. So this is just equal to negative I. That's simplifying that. Here we'll take 54 divided by 4. 54 divided by 4. We should know those pretty well. 13 goes into that with a remainder of 2. So we have a remainder of 2. So that's going to be equal to negative 1. 128 divided by 4. That's actually a multiple of 4. And the reason I can think that is because I know 4 goes into 100. So actually, whenever I do these, all I need to look at is these last 2 digits. I don't even need to worry about this 1 because 4 goes into 100. So I'm looking at the last two digits here, the number formed by the last two digits. I see 4 goes into 28 evenly. 4 goes into 28 7 times, remainder 0. And so if it's a remainder 0, that's this situation here. So remainder 0, this one's just equal to 1. Using that same thing I just mentioned, I only need to look at these last two digits, because anything bigger than that, 1,200, that's divisible by 4. So I just have to look at the 43. 43 divided by 4, that goes in 10 times remainder 3. And again, that's something you can do in your head. So we got a remainder 3. Remainder 3 from this one here, we know is negative I. So we should be able to simplify I to a power. The answer will always be either 1 or negative 1 or I or negative I. Now that we hopefully can do that pretty well, we're going to jump to this last slide here. So a pure imaginary number, this is the definition of a pure imaginary number. We don't really write capital I, we always use lowercase I. The product of a real number and I written in the form AI, where A is a real number. A does not equal 0 because you'd be multiplying by 0 and you just get 0. And I is the imaginary unit. So a pure imaginary number, we'll get into other types of numbers that have imaginary numbers in it. But right now, a pure imaginary number, some examples of that would be 3i, negative 6i. We could say the square root of 5i. We can have pi I. So any real number multiplied times I. And those are examples of pure imaginary numbers. And again, we'll get into other imaginary numbers that we wouldn't call pure imaginary numbers. And then we have a few examples here where we're going to be using imaginary numbers. So first thing, now we learned to simplify things like this in chapter 7. So we would be able to simplify the square root of 45 from chapter 7, but we have a negative square root of 45. So the first thing we do, and really the only new thing, is we're going to split this up into the square root of 45 times the square root of negative 1. Well, we know the square root of negative 1 is I. Depending on how well you can think through this, we can figure this out. This is, if we factored this, this would be the square root of 3 squared times 5. Square root of 3 squared is just 3. So we have 3 root 5 I. And that would be in simplified form. 3 root 5 I. Over here, this one's a little different. We don't write it that way. We don't want a square root of a negative, so we can say this is the square root of 5i times the square root of 6i. Square root of 5 times square root of 6, that's the square root of 30. I squared, but we learned earlier I squared, and this is really important, I squared is equal to negative 1. We should know that by heart, and we'll see that a lot, so you'll probably get used to that. So this, since that's just equal to negative 1, we can say this is negative square root of 30. And the last example here is actually a solve. This was under one of our last objective. We should be able to solve things in this form. X squared plus a number equals 0, and this is a positive. So what we're going to do, we're going to subtract 48 from both sides, so equal to negative 48. And then we would take the square root of both sides. We put plus or minus. X over here, we have a square root of 48, negative 48, so we're going to actually do plus or minus the square root of 48. And since it was a negative, you could put negative 1 here, square root of negative 1. Or once you get used to it, you'll probably just stick an I in there. 48, as you think through that, and if you have to do some work to the side, that's fine. But square root of 48, if you simplify that, that is 4 root 3 times I. And so if we go back to our objectives, we learned what square root of negatives are. We have the imaginary unit I. We simplified I. That's when we want to look at the remainder when we divide by 4. And we need to know those. We need to know if the remainder is 0, that thing will just be equal to 1. If the remainder is 1, it's equal to I. If the remainder is 2, it's equal to negative 1. And if the remainder is 3, it's equal to negative I. Those are those things you should know. The last thing, we just did this example where we solved a problem that looked like this, and we got I in our answer. And that's it for learning about pure imaginary numbers.